We now realize that we may need to revise every textbook on the history of the universe as a result of the James Webb Space Telescope upsetting the Apple car. After 25 years and over $10 billion on Christmas Day 2021, the James Webb Space Telescope was eventually launched into space by European Ariane 5 rocket decollage liftoff from a tropical rainforest to the edge of time itself. James Webb begins a trek back to the birth of the cosmos. However, Michio Kaku believes that we may need to completely rewrite all of the textbooks on the history of the universe's formation, because the James Webb Space Telescope has not only been launched, but it also quickly is altering the game. Scientists are astounded to see the Big Bang Theory disproved in front of the telescope. What then is the reality of our universe? You will get to know this and plenty more as we dive into the details of today's show. However, before getting started with the video officially, here's a quick reminder that you can subscribe for free and like the video so that we can boost the algorithm. Comments are most welcomed. Beyond the Earth, we can see that there is a vast expanse of space that is probably limitless, but that, for the most part, is still unexplored. However, thanks to the numerous scientific investigations and discoveries that are still being made, we can at least appreciate the complexity of the world we live in while posing questions about the origins of the universe, our very existence, and whether or not we are alone in it. Even though there has already been a lot of accomplished with technologies like rockets and satellites orbiting our planet, questions like these have spurred extensive space research and investment. However, one of astronomers and scientists' greatest achievements in recent years is the James Webb Telescope. Astronomical instrument James Webb, the Hubble Space Telescope, will be replaced by the enormous JWST space-based observatory. It is a collaborative effort between NASA, the European Space Agency, and the Canadian Space Agency. James E. Webb is honored with the telescope's name, the person in charge of NASA during the Apollo mission due to the JWST's ability to examine the universe in the infrared region of the electromagnetic spectrum. It is now possible to see through dust clouds and study far-off objects more clearly than ever before. More than twice as large as Hubble's mirror, its primary mirror is 6.5 meters, 21.3 feet in diameter. The JWST will be able to collect more light and produce higher resolution images thanks to this larger mirror. The near-infrared camera, NIRCam, also provides clear images of astronomical objects in the near-infrared range and is used for a variety of observations, such as observing exoplanets, studying distant galaxies, and studying the formation of stars and planets. The JWST will be able to study the early universe, the formation of stars and planetary systems, and the makeup of the atmospheres of exoplanets thanks to the mid-infrared instrument MIRI, which operates in the mid-infrared range. Also available is the near-infrared spectrograph NIRSpec, which is made to conduct spectroscopic studies in the near-infrared range. It is used to investigate the creation, evolution, and chemical makeups of exoplanet atmospheres. A fine guidance sensor and a near-infrared imager spectrograph are combined in the fine guidance sensor near-infrared imager and slitless spectrograph FGS mirrors. It will perform scientific studies such as observing exoplanets and the birth of stars, as well as precise aiming and stabilization for the telescope. The James Webb Telescope appears to be exceeding expectations so far and living up to them. In addition to giving us a clear understanding of cosmic truths, recent discoveries have been shattering long-held notions we had about the nature of the cosmos. 6 mysteriously and startling old galaxies have recently been discovered from the James Webb Telescope's first set of data, which NASA recently released. Michio Kaku, a renowned theoretical physicist, states that we might have to rewrite all the scientific books on universe formation in response to this. But really, how serious can the situation be? You might be wondering this until you learn that this time our favorite Big Bang Theory is in trouble. Scientists and astronomers have recently taken to Twitter in droves to discuss the startling findings that resulted from the public release of the first batch of data gathered by the James Webb Telescope. Scientists have identified mysterious ancient galaxies from this data, leaving them perplexed. The excitement is growing by the minute as the startling discoveries only point to one thing: the Big Bang Theory, which provides us with a precise account of the origin of our universe and how it has evolved to become the various stars and galaxies that are recognizable to us, is the main casualty in this enormous explosion of information. And the world's shock started with the recent publication of images taken by the James Webb Telescope of 6 ancient galaxies that appear to have formed between 500 to 700 million years after the Big Bang. If not for the evidence currently in front of our eyes, the established galaxy formation model, which we previously held dear, states that galaxies take billions of years to form. This formation period could have sparked complete opposition, The realization that these galaxies have fully developed in 500 million years is shocking. The most recent discoveries call into question our understanding of the length of time it takes for galaxies to form, and how far back in the universe galaxies first began to form. The Big Bang hypothesis, a general recognized scientific hypothesis explaining the creation and history of the universe, should have succeeded in giving us answers had it not been for the recent discovery made by the James Webb Telescope. The Big Bang theory proposes that the universe was created in an incredibly hot and dense singularity 13.8 billion years ago. It then underwent a rapid expansion known as cosmic inflation, which caused the cosmos to cool and become less dense based on observations of the universe's expansion made by the astronomer Edwin Hubble. Belgian physicist and Catholic priest Georges Lemaitre first put forth the idea of the Big Bang theory in the 1920s. The British astrophysicist Fred Hoyle first used the term Big Bang to refute the theory, but it eventually stuck because of this theory. As the cosmos grew and cooled, matter and energy started to develop. Cosmic microwave background radiation, CMB, is a phenomenon that occurred when the universe became transparent to the light approximately 380,000 years ago and allowed photons to move around freely. As one of the most compelling pieces of evidence for the Big Bang theory, the CMB was predicted by the theory and later discovered in 1965, making it one of the strongest examples. As time went on, matter and energy continued to clump together as a result of gravitational attraction, creating formations like galaxies, stars, and planets. Although galaxies and galaxy clusters formed large-scale formations that were divided by huge cosmic voids, the distribution of matter in the universe was not uniform, and the Big Bang theory also explains the observed redshift in light emitted by far-off galaxies, which is evidence for the universe's continuing expansion. As the universe expands, light from these galaxies' wavelengths stretch and cause a shift towards the red end of the electromagnetic spectrum. The narrative continues, but let's take a closer look at the theory in the context of the recombination and reionization stage so that you can better understand what we're getting at. The recombination phase refers to the time in the universe's history when the plasma of charged particles, primarily composed of protons and electrons, cooled down to the point where electrons could combine with protons to form neutral hydrogen atoms. When the universe's temperature cooled to about 3,000 degrees Celsius after the Big Bang, that happened some 380,000 years later. The previous era, also known as the photon-baryon domination age, was characterized by the frequent collisions of light photons with charged particles, which prevented them from freely traveling and forming stable atoms. The universe remained opaque due to this photon scattering, but when the temperature dropped, the average energy of photons also dropped, allowing them to go farther without colliding with anything. At around 3,000 degrees Celsius, the temperature became low enough for electrons to bind with protons, forming neutral hydrogen atoms. Recombination is the result of the dissociation of photons from matter photons, which allows them to move freely through space and causes the recombination event. The recombination event is of tremendous significance since it marked the point at which the cosmic microwave background radiation CMB was emitted. Cosmic background radiation CMB is a soft glow of radiation that permeates the entire cosmos and comes from the hot plasma of the early universe. After recombination, the universe went through a period known as the Dark Ages, during which there was no substantial light sources or ionizing radiation, and there were no stars or galaxies either. During this period, the cosmos was largely transparent to radiation. However, the first stars and galaxies only began to develop a few 100 million years after the Big Bang. The high-energy photons from the stars were energetic enough to strip electrons from the hydrogen atoms, resulting in the ionization of neutral hydrogen. These objects emitted intense ultraviolet radiation that interacted with the neutral hydrogen atoms of the intergalactic medium. The name of this process is reionization, because it signifies the change in the universe's primal neutral state is an ionized state. Reionization is seen as a momentous event. This ionized gas played a critical role in the subsequent formation and evolution of galaxies and other large-scale structures in the cosmos by allowing light to travel freely and making the universe transparent once more. Reionization is generally thought to have happened gradually over several 100 million years, beginning in the small regions of the universe where the first luminous objects formed and eventually extending throughout all of space. Now that the first group of stars had started to form, they were enormous stars made of simpler elements like hydrogen and helium. These stars were the first population of 3 stars that we could not see them, but since they did not contain heavier elements, allowing them to be considerably larger than our Sun, even dozens or hundreds of times its size, astronomers think that these initial stars arose roughly 560 million years after the Big Bang, since their telescopes were not powerful enough to see them. Much though these initial stars eventually went supernova, other, much bigger stars also created and burst. The Big Bang Theory-based analysis of the universe's genesis may have left out some important details according to recent revelations from the James Webb Telescope. Our current understanding is being tested by these astounding new galaxies, which have us wondering where these surprising cosmic beauties came from. Likewise, continuing the pattern of groundbreaking discoveries made by the James Webb Space Telescope for NASA. Following the pattern of groundbreaking findings made by the NASA's James Webb Space Telescope, the telescope has gone further to reveal the universe's oldest ancient galaxy yet seen. The image supplied by NASA shows what appears to be a red blob in the distance following the two preprint articles that were published and added to the scientific journal repository providing the initial examination of the issue. But this object is not just any blob, it is the oldest known galaxy in the cosmos at the moment. Its name, GLASS Z13, comes from the redshift distance at which it is located. After exceeding its predecessor, the amazing GNZ11, by about 100 million years, GLASS Z13 has now acquired the distinction of being the oldest galaxy on record. This incredible celestial entity was reported to have emerged just 300 million years after the catastrophic event known as the Big Bang. Despite its enormous weight, Z13 is expected to have a large core that can consume 1 billion suns, despite the fact that this young galaxy is considerably smaller than our own Milky Way, our familiar cosmic abode. While the Milky Way spans a distance of around 100,000 light-years, GLASS Z13 only takes up a few thousand of those. Surprisingly, the attentive researchers also discovered another nearby object, GLASS C11, which is just as old as its predecessor. Both galaxies are rather small, with GLASS's at 11 measurements, 2,300 light-years, and GLASS Z13 measuring about 1,600 light-years. These remarkable discoveries, according to astronomer Rohan Naidu, have led to the discovery of two strong candidates for far-off and old galaxies. Because of the enormous cosmic distance separating us from them, the universe was only a few hundred million years old when they formed their nation. The possibility of finding galaxies that are less than 200 million years old also looms on the horizon as a result of the James Webb Space Telescope's potential to peek even further into the cosmic fabric. According to the researchers, this project is crucial to completing the JWST team's aim to create a thorough spatial map that will serve as a turning point in our cosmic exploration. In addition to finding the oldest galaxy and 4 odd galaxy clusters, the James Webb Telescope's data also led to the discovery of an additional startling and bizarre-looking galaxy. This galaxy is the smallest one ever discovered. It is actually not expected to exist according to experts, as this contradicts every model and need that had previously been thought to be necessary for a galaxy to exist. This galaxy is only 16 kilosparks across, which is quite tiny. And if you want to understand how little the galaxy is, you may compare it to the size of our Milky Way, which is roughly 40,000 kilosparsecs. This is one of the strangest things that has ever been witnessed in recent times. The redshift of the galaxy RxJ2129Z95 is 9.5. The image of the galaxy is faint because of its distance, but it was brightened by a 2.5 billion light-year galaxy cluster at gravitational light. In addition to its size, another peculiar aspect of this odd galaxy is how quickly it produces stars. In fact, this odd galaxy is a star factory, creating a huge number of stars in a race that is both terrifying and impractical compared to all the other much larger galaxies. Although some have questioned the claim that this is a galaxy and not a star cluster, all evidence points to this being true. Although it is small for a galaxy, it is still much larger than a star cluster. The galaxy is thought to have formed between 500 to 550 million years after the Big Bang. While others attempt to explain why this specific galaxy is producing more stars than is considered realistic, according to certain theories, there may be a process at work that has as many stars as it can produce. On the other hand, it's possible that we still don't fully understand how stars are created. Regardless, we must give credit where credit is due for the James Webb Space Telescope's initial discovery of these old galaxies. The James Webb Telescope was able to capture phenomena that its forerunners were unable to. But how did it achieve it? Well, keep in mind that the redshift notion will help you better understand how the JWST detects infrared radiation. Redshift appears to be moved towards longer wavelengths, more especially towards the red end of the electromagnetic spectrum. The universe's expansion as a result of redshift. When an item in space travels away from a viewer, the light it produces is stretched or spread out as the distance between them widens. The term redshift refers to the shift in wavelength caused by the stretching towards a longer wavelength that corresponds to the red portion of the spectrum, similar to how the pitch of a sound varies as a source moves farther or closer to an observer. The wavelength of light changes as a source moves farther or closer to us in space. Redshift is closely related to the Doppler effect noticed with sound waves. The cosmos is expanding, which causes the wavelength of light to be stretched in the case of redshift. Cosmology's understanding of redshift is crucial because it helps us understand how the universe is expanding and how quickly galaxies are vanishing from our view. Astronomers can determine the distance of distant galaxies from Earth using the redshift of their light, which enables them to investigate the universe's development and large-scale structure. And it is astounding that the initial batch of James Webb Telescope data published by NASA contains only a small portion of all these weird findings of ancient galaxies that have been long concealed, but are now discovered and are generating such a stir in the scientific community. This amply displays the quirks of the James Webb Telescope as well as its capabilities, and provides evidence that there is still much more to learn about galaxies than we can possibly imagine. What do you think of these extraordinary, unusual galaxies that the James Webb Space Telescope has photographed? Do let us know in the comment section below. If you enjoyed this video, please hit that thumbs up. It will help us to understand our audience and allows YouTube to suggest similar videos to you. Thanks for watching, and we hope to see you at the next one.